Well, hello there. I'm Mr. Von Ah, and I'm so glad you came to join us. Hey, we are learning a very important skill today. We're learning how to solve equations. Okay, in the last video, I gave you some strategies, some tools on how to solve equations. And I have them still up here. It probably doesn't look like a whole lot because it's pretty crowded. But the first thing we learned was distributive property. Second was combining like terms. Third was using the addition principle. And last is the multiplication principle. And I put them in this order because typically, whenever you're solving an equation, this is the order that you're gonna work in. All right. The very last thing you're going to use is multiplication principle. He's going to finish it off with that. All right. So I have three equations, and we're actually going to do another one at the end. All right. And we're going to go from easy, and we're going to get harder as we go along. Okay. And we're just going to use these strategies to help us solve these equations. All right. So the directions are: solve the following equations, and the first one says 3x equals 27. Now this one's pretty easy, so you can probably just figure this one out in your head. So I just kind of look at my toolbox here, and I ask myself, do I have any distribution that I need to do? No distribution, right? No parentheses. Do I have like terms? No like terms. Remember, like terms are terms that are alike on the same side of the equal sign. Do I have any adding or subtracting going on up here? No. So I go to my last thing, multiplication principle. Do I have multiplication or division going on? I do. Right here, did you see that in multiplication? That's 3 times x. Anytime you got a number right next to a letter, it's a multiplication. All right, so I need to use the multiplication principle. The multiplication principle says this. What I want to do is I want to multiply by the reciprocal, or I want to divide by the number in order to get a result of 1. All right? Multiplying by reciprocal and dividing are the same thing. So I look here, in this case, dividing is going to be a lot easier. All right? So how do I get rid of that 3? Well, I just use my good old multiplication principle. The inverse of multiplication is division. All right? So I got to do that to both sides. Remember the golden rule of algebra, do unto one side as you do unto the other. All right, so I got 3 divided by 3, which is 1. And I end up with x, or 1x, equals 27 divided by 3 is 9. All right? So that is called my solution. That's my solution. It's the value of my variable that makes this equation true. And I can check that solution. If x equals 9, I should be able to substitute 9 in for x. 3 times 9 is indeed 27. All right, so it checks out. All right, that was a simple one. All right? Let's go something a little bit more difficult. All right, so number 2, I have 4x minus 8 equals 12. All right, I look at my steps. I don't have any distribution. I don't have any parentheses there, right? Do I have any like terms? Well, you might say, well, these two are alike, but they're not on the same side of the equal sign, right? So they're not like terms. Do I have any adding or subtracting? I do have subtracting, don't I? So I need to take care of that first. Okay, so the addition principle says, hey, we're just going to add the opposite to a number to eliminate that number. So what's the opposite of negative 8? Positive 8, right? And just do that to this same thing to the other side. Think of an equation as a balance, right? If you added 8 pounds to this side right here, you're going to get like this, right? How do I make that balanced? Well, I just add 8 pounds to this side, and now it's balanced again, right? So this is going to cancel. Okay, negative 8 plus 8, 0. Okay, so I get, let me go this way. 4x, I still have the 4x. Don't have that negative 8 anymore, right? That equal sign. Now I have to do this arithmetic, 12 plus 8. That's just simply 20. Okay, now I move down to my multiplication principle. I am multiplying 4 times x. See if you can solve this for x all on your own. Pause the video. All right, what did you get? Did you show your steps or did you just guess? Make sure you show your steps, because I realize this is easy. I know x equals 5, right? But it's not usually going to be that easy, so you have to learn the proper steps. Don't take shortcuts. All right, so I'm going to divide. Why? Because that's the inverse of multiplication. I'm going to divide by 4 to both sides. And look what that does. I get 4 divided by 4, which is 1. Remember, we're trying to get a result of 1 when we're doing the multiplication principle. So I end up with x equals, well, 20 divided by 4 is 5. That's called the solution. It's the value of the variable that makes this equation true, and I can check it. Okay, let's take a look. X equals 5. Everywhere I see an x, I'm going to substitute a 5. Right there, so 4 times 5 is 20. Minus 8, does that equal 12? 20 minus 8 does equal 12. It checks out. I don't need any answer key. All right, let's take a look at another one. Number 3. I have 2y plus 7 minus 3y equals 4y plus 15. Hey, we're getting a little more complicated, aren't we? Okay, but once again, we just start at the top. Do I have any distribution? In other words, do I have one number that needs to be multiplied by 2 or more numbers? Well, I don't, because I don't have any parentheses, do I? So that's off the table. Okay, how about combining like terms? Do we have any terms that are alike, that are on the same side of the equal sign? Let's see, right here. I got a 2y and a negative 3y. Those are alike, and they're on the same side of the equal sign. So let's go ahead and combine those. Okay, so what's 2y minus 3y? Well, 2 minus 3 is negative 1, right? So I'm going to get negative 1y. You could just put negative y. Now I still got that 7. So I'm going to add that 7, right? So I just combine these two terms right there. So I end up with negative 1y plus 7 equals, are these like terms? No, they're not alike. That's a constant. This is a coefficient with a variable. So what do? I just bring them down. Okay. Any more like terms? These are not like, so I'm done with combining like terms. So now I move to addition principle. Am I adding or subtracting anything? Yeah, I sure am. I'm adding 7 here and I'm adding 15 there. Okay, so you have to remember what your goal is. Your goal is to get y by itself on the left side. I want to get y all by itself on the left side. Well, looky here. I got a negative 1y. I have a 4y over there. I have y's on both sides of the equation. There's lots of different things I could do here, right? I could subtract 15, I could subtract 7 here, I could subtract 4y, I could add 1y. There's like 4 different things I could do. I'll show you my preference. I like to get my variable on the left right away, okay? Because I know I'm going to need to do that. So I'm looking here, I have a variable on the right. I don't want him on the right. I want him on the left. So I want to get rid of 4y. Well, how do I get rid of 4y? Well, it's very simple. You just subtract 4y, and now it's gone, right? And as long as I do it to both sides. So I'm going to put negative 4y over here. Now where should I put it? Should I put it under the negative 1y or the 7? I want to put it underneath its like term. All right, so negative 4y, I'm going to put him right there. All right? So watch what happens. 4y minus 4y, that cancels. Okay, now let's see what I end up with right here. So I got negative 1y minus 4y. What's that going to be? Well, you can think about it this way. If you have negative $1 and you lose another $4, now you got negative $5. All right? So I got negative 5y. Okay, so I just combine these two terms. Now I'm going to bring everything down. Plus 7 equals, this is canceled, so I'm just have the 15 on the right side there. All right. Now, I ask myself again, do I have any adding or subtracting? And the answer is, I do. I have a plus 7 there, don't I? Okay, so I successfully got all my y's to the left, but I don't want any numbers on the left, do I? I want to get rid of all my numbers and put them on the right. That's my goal. So how do I get rid of a plus 7? Well, the addition principle says we'll just add the opposite. Add the opposite. Okay, what's the opposite of 7? So I'm going to add a negative 7 to both sides. That's going to cancel, right? So now I'm left with negative 5y equals 15 minus 7 is 8. All right? All right. So do I have any more adding or subtracting? No. There's a negative. That's a negative 5 times y. So I'm done with addition principle. Now I move on to multiplication principle. I am multiplying here. All right? So I'm going to go ahead and divide by negative 5. You have to divide by negative 5. Because negative 5 divided by negative 5 is going to give me a positive 1. Do that to both sides. A big mistake people make is they do this. They just divide by 5. No. If you do that, you're going to get a negative 5 divided by a positive 5 is a negative 1. I don't want negative 1y. I'm going to divide by negative 5. All right, that's going to give me 1. Leaving me with y equals 8 over negative 5 or negative 8 fifths. Negative 8 fifths. By the way, you'll see that I moved the negative sign from the bottom to the top. It doesn't really matter. You could have negative 8 over 5 or you could have 8 over negative 5. It's the same thing. Now let's say they wanted you to show this as a mixed number. How would you change that to a mixed number? A mixed number is an integer with a fraction. Well, it's real simple. You just divide. All right, so how many times does 5 go into 8? Well, it only goes in one time. Remainder 3. So my answer would be 1 and 3 fifths. See that? Your remainder forms the numerator. So that's going to be negative 1 and 3 fifths. So it just depends on how they want you to show the answer. If they want you to show it as an improper fraction, you're done. If they want you to show it as a mixed number, well, now you know how to change it. All right, let's do one more. And I'm going to have to come on up here on the top here. Let's do one more here. What if I have number 4? 12b minus 6 times b minus 1 equals 18 minus 4b. All right. Oof, getting long and ugly there, isn't it? All right. So again, I just start at the top. I go here and I say, hey, do I have any distribution? And I look here and say, oh, yeah, look at that right there. I'm going to have to distribute that -6 to both of these terms in there, right? So I start right there. All right? So I'm going to just bring down my 12b because I'm not going to do anything with it right now. So -6 times b is -6b. Careful. Make that b look like a b and not a 6. It's 6b, not 66. And -6 times -1, well, a negative times a negative is a positive, and 6 times 1 is 6. All right, so a common mistake is students will forget, and they'll just put a -1 there. These parentheses mean that, hey, this -6 is being multiplied by everything inside of those parentheses. All right, so it's a +6. And I just bring everything else down. I'm not doing anything with the 18 yet or the -4b. Okay, no more distribution, done with that one. Now I move down to combining like terms. Do I have any like terms? Let's see. Well, look at this. Same side of the equal sign, same terms. 12b minus 6b. That is going to be, well, 12 minus 6 is 6. So I get 6b. So I'm just going to write everything else down. Let me tell you something. One of the most common mistakes that students make is they take shortcuts, they get lazy, and they don't write down the steps. If you do that, you're asking for trouble. All right? Take the extra 3 seconds and write it out. All right? Okay, let's see here. I don't have any more like terms. These are not like, and these are not alike. And these are not alike because they're not on the same side of the equal sign, right? All right, let's go to addition principle. Am I adding or subtracting? Yeah, I'm adding and subtracting. All right, so remember what I like to do. I like to get the variable all the way to the left. All the variables to the left. So see this -4b? I don't like that. I want to get him over here. Okay, how do I do that? Well, I have to add his opposite. Remember, the addition principle is adding the opposite. So plus 4b to both sides, and look, that just cancels, doesn't it? All right, I need some more space here. Okay, now what do I have? 6b plus 4b is, that's 10b, plus 6, what? Bring everything down, equals 18. All right, and that part is gone. Okay, now do I still have more addition principle to do? I do. See that adding? So I got to add his opposite. The opposite of 6, -6. And I just do it to both sides. See how simple this can become? Once you get the hang of it, it's not too hard. That cancels. So I get 10b. All right, let's bring it down. Equals 18 minus 6. Is that 12? All right, so I get 10b equals 12. I don't have any more adding or subtracting to do, so now I can move on to multiplication principle. The inverse of multiplying is either the reciprocal or division. So I'm going to divide both sides by 10. Okay, 10 divided by 10 is going to give me 1, right? I'm looking for a result of 1. Okay, so I get 1b, or just b, equals what? 12 divided by 10? Now, I did this on purpose because a lot of times we think that our answers have to come out to a nice whole number, right? Here's the reality. In real life, almost always your answers come out to be fractions and decimals. All right? Only in math classes do we contrive our mathematics to make them come out nice. All right? So we got an ugly number there. What do we do with it? Well, first of all, that needs to be simplified. Okay, here's the way I simplify fractions. What's the greatest common factor of 12 and 10? Well, what's a factor? Well, factors are just numbers that divide into 12. What are the numbers that divide into 12? Let's look at the factors of 12. 1, 2 goes into 12, 3 goes into 12, 4 goes into 12, 6 goes into 12, and 12 goes into 12. What are the factors of 10? Let's do that in green. Factors of 10, well, 1 goes into 10, 2 goes into 10, 3, no, 4, no, 5 goes into 10, and 10 goes into 10. So what's the greatest common factor? Let's see, 1, 2, 5, well, it's going to be a 2, isn't it? 2 is my greatest common factor. So I'm able to divide the top and the bottom by my greatest common factor. That right there is my greatest common factor. That's how I simplify fractions. All right, so I get 12 divided by 2 is 6, and 10 divided by 2 is 5. That's called an improper fraction because the numerator is greater than or equal to the denominator. If I want to show that as a mixed number, let me show you a quick way to do that without doing all the long division stuff. How many times does 5 go into 6? Once. How many leftovers are you going to have? Just 1, right? And then what's your denominator? 5. All right, so B equals 6/5 or 1 1/5. All right? So you can see how just knowing these tools right here, having these tools in your tool chest, you can solve any linear equation. All right? I hope this was helpful to you. Don't forget to subscribe to my channel. You can get notified of all my videos. And also I've included the notes for this lesson in the description below. Take advantage of that. All right? Good luck, my friends. Keep up the good work, and may God richly bless you.